That's okay. That's not your fault. Okay, so now what? Is it clear why we switched the inequality symbol? Okay, now what? Right. So we know this is our contract. How do I factor this? First day of classes, we had this contract. Yes? Yes? Okay, which is? Good. You're on the right track. Thank you. Very good. Good. Now we just looked at that chart. If you like to use it, I do. Because I think it's self-explanatory and I don't have to do too much. Yes, it's a lot of writing, but it's not a big deal. Which numbers go in the chart at the top?
16.
Both of them have the same positive leading coefficient. What would be the sequence of signs then for a linear function with a positive slope?
Negative, positive.
Right. So then in the first subinterval, sign. In the middle. Good. Which sign will I pick? What does that say? Good. So is there a product? Is the product ever negative? Yes, Nick? Yes. So the solution will be x, the domain. This is the domain, actually. X is in what interval, please?
Between negative infinity and 16. So parentheses, negative 16.
It's right here. I cannot choose this because it's positive.
That's where it's screwed up. Okay.
So it's a bracket negative 16 to 16. Therefore, which interval will you graph this function on?
Negative 16.
I would choose negative 20, 20 so I can see a little bit to the sides, but the function doesn't exist anywhere else but between negative 16 and 16. So if you go to here it is. If you put this function in y equals as I would put 256 minus x squared, close the parenthesis, and caret in parentheses 1 divided by 4 because that's what the fourth root means, power 1/4. And I go to the viewing window. I will say negative 20 to 20 with a scale of 5. And I'm not really sure how far up or down, but I'm going to say for now 10, 10, negative 10, 10, and I got it. Okay? So when I graph, I already see it. That is the graph of this function.
Okay, so for the viewing window,
It's basically a half of a circle. I'm sorry?
For the viewing window, you just have to solve the equation for it.
You have to think. Yeah. Calculator will not think for us.
Right.
The calculator will do what we want the calculator to do, but it will not think for us. Yeah, I have to. That's why I don't want anyone to say, well, without the calculator, I can't do anything. Okay, is this clear? Good. Other questions? Is there anything else?
So I had started with some of the word problems. So,
Okay.
Number 47. I don't know if this just goes like.
47 page something.
Page 68.
Page 68.
Yeah. I could look that up with that.
47. 47. Framing a painting. Only paints with watercolors on a sheet of paper 20 by 15. Okay, we see that. He then places the sheet on a mat so that a uniformly wide strip of the mat shows. Let me show the picture. Here it is. So this is, nobody can see though. Okay, here it is. So we have the 20 by 15, and we have a frame that is X inches all around the picture wide. The perimeter of the mat is 102 inches. So this is 102 inches, whole thing. This plus this plus this plus this. Because it's the mat, the whole thing. How wide is the strip of the mat showing around the picture? So we are asked to find x. So this is the situation. Here's the picture. This is 20 inches by 15. And this is problem 47 on 68. And this is x. And we have the perimeter of the whole thing to be 102, I think. Is it? 102 inches.
Yeah, perimeter of the mat.
Okay. So does anyone have any idea on this?
Would you have to set up like the piecewise, like
Nope.
It's a rectangle, right?
Yes.
So like, not x, because you're already using x. So like 2y plus like 2
So you're saying you're going to write the perimeter
equals
from here all around will be 2 times the length
minus 20.
plus 2 times the width. Good. Can anyone give us the perimeter of the length of this figure?
20 plus 2x.
Say it again.
20 plus 2x.
Of course. This is 20 plus 2x. Can anyone give us the width?
15 plus 2x.
And you can take it from here. Good. Is that good enough? Good. Do we understand it? We understand how we got that. Good. Anything else? Other questions? Is there anything else?
Yep, I have people are trying to find questions. So number 73 on section 1.9, so page 104, number 73.
73 and 104. Yes.
I had a problem with that word problem.
If there's another in a column C, then your height x in feet above sea level is related to the farthest distance, okay, that you can see by, okay. Graph the equation for this interval. So you have to put in the calculator between 0 and 100. And in part B, how high up do you have to see to be able to see 10 meters? So y is the farthest distance, 10 meters, 10 miles, I'm sorry. So y is 10. So this is in 73 on page 105. And we have 10 equals the square root of 1.5x plus x over 5280 squared. What type of equation is this? Good. How do we, it's not rational. It doesn't have x in the denominator. Good. How do we solve a radical equation?
Square both sides.
Okay, and take it from there.
Okay, that's where it's.
Yeah, and then it becomes a quadratic equation. You can use the quadratic formula for it. So you'll have 100 equals 1.5x plus x squared over 5280 squared. And you can use the quadratic formula. Do you maybe need to remind you the quadratic formula or?
Sure.
So ax squared plus bx plus c equals 0. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So after you square, it becomes quadratic, and you can plug in the numbers. But I will recommend eliminate all fractions first. get clean A, clean B, and clean C as numbers, not fractions. And then you can plug it in. Anything else? Is there anything else?
Number 87 on page 80.
87 on page 80. 87. Yes. What is the problem with this?
I don't know. I quite have. I wrote it down for a reason. I don't know why.
Okay, so you move A to the other side, so we have this. You will have to divide both sides by -1 or multiply both sides by -1. And now you ask yourself, what is it? Is it this or is it this? Since it's less than or equal to, it must be this, in between, as we discussed. So you change it into -2, less than or equal to 2x minus 1, less than or equal to 2, and you take it from there.
Can you do number 85?
Yes, Nick, is this okay?
Yeah, that's fine.
Okay, 85, yes.
It's on 1.6, page 67. Or
85 on page 67.
It's like much as like in those pages, so it's close to that. It's like,
And you're looking at 85.
yeah, number 85.
85. We did it in class last time.
Is the the count?
Yes,
Oh,
we did this problem in class last time. Please redo the problems we do in class. That's the first step you have to perform. That's why I choose these problems. Uh-oh. What is this? Okay. Anything else? Okay, we're trying to make headway with chapter 2 as much as we can today and schedule our first test. I'm already not you, I am already way behind. Okay, so let's talk about functions. And 2.1, let's talk about the definition. Can anyone give us an idea of what would a function be?
So, in my line of work, a function is something you can reuse over and over again.
Right, it's something that you create an input or have an input, you plug it in that function, and you will get an output, right? So a function requires an input, an output, and some sort of definition. So if we are looking at 3 possibilities, possibility 1, possibility 2, and possibility 3, I'm going to put in some numbers. You can put any number you want. You don't have to put the same numbers I do, or I don't even have to put numbers in. So I'm going to say this is my input. It's in here in this set, or x values. The result is right here. It's the output. It will be found in this set, or y values. Now I can create the relationship, because just input and output doesn't create a function. I have to show you what is the mechanism, how I put in the input and how I get the output. And here's just something I select right now. Let's say this corresponds to this. This number corresponds to that number, and this one to this number. Or this input to this output, and so on and so forth. I'm going to present the second situation here. Okay? And I'm going to present the third situation here. And let's discuss all these 3. The first one, because each x value corresponds to only one y value in the output set, this is a function. So a function in general represents a function is a relation or a correspondence that makes each x value correspond to only, that's the key word, only one y value. So let's look at the second situation. Is the second situation a function? Yes. Each x corresponds to 1y, each x corresponds to 1y, each x corresponds to 1y. And this is a function as well. However, at the end of this chapter, we will differentiate between these two. This one has a property that this one does not have. Exactly, it is one-to-one. Excellent. Good job. Yes, it is one-to-one. Why? Because if I want, for this one, if I want to look backwards, going backwards, I can create a function. This corresponds to only one. This corresponds to only one going backwards, and this value corresponds to only one y value. So this function has a property that's called one-to-one. Each y value also corresponds to only one x. This one is a function, but if you want to go backwards, that will not be a function. Therefore, this is not one-to-one. Okay, what about the third situation? Not a function. That has a name. It's possible. It can happen in real life. It's called a relation. Also, these two sets have specific names. It doesn't matter if it's a function or relation. This set, for both, is called domain. This set, for all these situations, is called range. So values of y, range. Values of x, domain. Okay. I would like to discuss domain and range for functions. And also looking at some graphs, because I want to refresh your memory on one other item. So let's suppose I'm also given graphs now. I'm given this graph. Let's say I'm given this graph. And let's say I'm given this graph. And the question is asking now, is asking us, can I, by simply looking at the graph, can I identify whether the graph corresponds to a function or not? Good. By the vertical line test, vertical line test, through the domain, of course. There is no point for this one to draw a vertical line here. It's not going to tell me anything. I have to draw vertical lines through the domain of that, whatever it is. Here, it's not going to say anything. So, by the vertical line test, is the first one a function or not?
Yes.
Yes, indeed. Is the second one a function? Very good. Relation. Is the third one a function? No. Relation. Another idea that I would like to remind you of or refresh your memory on is, let's suppose, what is the function notation, first of all? Yes. All functions are denoted by a name and the independent variable inside. I can have t of p. So the function is t, and the independent variable is lowercase p. I can have g of t. The function is called g, and the independent variable is t. And of course, our favorite f of x. The function is called f, and the independent variable is x. However, all these are the same with y, all of them. You can ask, why do we need two notations? It depends on what we're doing. So if I'm asking you to evaluate a function, I'm not going to say evaluate y for 3, mainly. I will say find f of 3. So they both mean the same thing, and they are used interchangeably. One is better than the other in different situations. Okay, now here's another thing. For example, I'm given this function. Let's say 2x cubed minus 3 divided by 4 minus x. What type of function is this? And if I ask you to evaluate it for 0, what will you say? What will you do? Right, you will have 2 times 0 to the third minus 3, 4 minus 0 is negative 3 over 4, so it's negative 3/4. But what is more important here is, what does the function tell me? What does it say? What does the function do with the input in order to get the output? So, what does the function do to the input to get the output? And here's how I look at the function, and this is very important to understand. So this pattern tells me this: f of whatever equals 2 times whatever to the third minus 3 over 4 minus whatever. This is the pattern. This is what the function is doing with to any input. So if you say the input is a plus h, then this is a plus h, and this is a plus h. If you say the input is 0, then this is 0, and this is 0, and you perform the calculations. Does it make sense?
Yes.
Okay, because I'm going to get to something very important, and I can look at it right now. This is crucial for calculus. I gave a quiz on this. I've been talking for 2 weeks about the same thing with my students in calculus, for 2 weeks. And I gave them a quiz. Only one student understood or knew what I was talking about. One. And that's not acceptable. And that one was in my pre-calc class, by the way. Nobody else understood what they have to do. So I'm going to talk about it right now. Okay. So let's say this is a function, f of x. And I would like you to tell me, if I say that a point P is on this function, and I say that its x-coordinate is x, can anyone give us the y-coordinate? Okay, let's come back to this example.
It's gonna be 0 something.
So let's go back to this example. So we had this function, and I said, please, let's evaluate it at 0. What did you do with that 0? Ah, thank you. And what is the point that you just determined?
0.
Okay, perfect. Stay with me. I'm telling you that the x-coordinate of P is x. What will be the y-coordinate of P?
P minus x. Yeah, what?
What's the function?
F of x. Very good. Very good point. So then what is the y-coordinate of P?
Whatever x is.
Y?
Or, what did we just say? Y is the same with what? There is no P.
So the output. It's the output.
Which is? Exactly. Exactly. We have to understand this. If we can understand this, we can go beyond it. So now, for a moment, if I say to you, I have a function f of x, and I have a point with x-coordinate a, can you please give me the y-coordinate of this point?
It's f of x.
Of
Of a.
f of a. Very good. That's okay. Good. We understand that? If we have a function and we have the x-coordinate of a point that is on the function, one more time, how do we find the y-coordinate of that point? Plug it in. Plug it in. Is this clear? Perfect. Okay. Stay with me. So then the coordinates are x comma f of x. We agree? We will not forget this. This is crucial. Nick?
Just to clarify.
Yes.
The x is always the input to your x value in your coordinate.
Right. And it always has to be the first.
And your y is the output of your function.
Yes.
Okay.
Or f of x.
Or
F of x or y is the same. Okay, they're the same. Good. Now I would like to create another point. So I'm going to create a point here. And I am going to say that the point is to the right hand side of B. Doesn't really matter. And I am going to say that this point is Q. And its x coordinate is x plus this distance. I am going to denote this distance by lowercase h. So the x coordinate of Q will be x plus h. Now I would like you to give me the y coordinate of Q.
it's going to be f of q. Or no, sorry. So your y, you have to plug in f of x.
F of x plus h.
Thank you. F of x plus h. Very good. If the x coordinate is blah, the y coordinate has to be f of blah. Better?
Yeah. Makes
Perfect.
sense.
Okay, now I would like you to tell me, how do I determine the slope of this line, which is called, it has nothing to do with trig, it's called the secant line. It is a secant line because it crosses the graph of the function in 2 points versus a tangent line that will only touch in 1 point. So I would like you to determine for me, or tell me what to write for the slope of the secant line. PQ. Yes, I'm ready.
F of x plus h.
Excellent. Yes,
F of x.
excellent.
X plus h.
Over x plus h
Minus x.
minus x. What does this represent? So let's put some explanation to this before we finish it. Okay, so let's try to understand what this means. If I am given the function and I am trying to determine the average rate of change between point P and point Q, this is what I get. That's the slope of the secant line as well. But it's also the average rate of change of this function between the point P and point Q. Is that clear?
Say that again, please.
Average rate of change of the function between P and Q. And it's also the slope of the secant line between P and Q. Now, of course, I'm going to eliminate these two because they cancel out. And this is f of x plus h minus f of x divided by h. This is what we call, and we have to, at this point, I'm not asking you to memorize this, but eventually you will have to. Okay? This is called the difference quotient. And also I will write the average rate of change of f of x between what?
EQ.
Exactly, thank you. We will be asked numerous times in this course to determine, simplify the difference quotient for any type of function.
So it's just a slope, basically.
It will look differently for different functions. This is the general form. It is the slope of a line, but it's the average rate of a function, rate of change of a function between 2 points. Good. So I'm going to choose a function. Please give me, or you are going to choose a function. Please give me a quadratic function.
X squared minus 4x plus 2.
Excellent example. And I would like us right here, right now, to find and simplify the difference quotient. Ready? Where do I start?
Put it in point sum form. No, wait, sorry, factor.
Bracket.
Okay. This is the formula for the difference quotient. I am asked to find this and simplify it. What do I find first? So let me write the difference quotient one more time right here.
That's gonna be the same no matter what.
Say it again.
That's gonna be the same no matter what.
For any function, but the outcome will not look the same. But the difference quotient, as you noticed here, Shane, you asked me, what is a function? I didn't give you a function. This is the general form for any function. You specifically, and you're right. You said, what is the function? And I said, I'm not giving it to you. It's f of x. So based on any function f of x, we determine that this is the difference quotient. Okay, so then, what do I have and what I don't have in the difference quotient? This is a little piece. I can't change that. I can't simplify it any further. That's it. I cannot do anything to this. It's the function you just created for me. What piece I don't have yet? Indeed. So let's, on the side, determine f of x plus h. How do I determine that? That's why I did this. And that's why I gave the example of a plus h. Because I want you to connect the information and tell me how to write f of x plus h.
People in H.
You put in x plus h wherever x is in the formula.
Of course. Absolutely.
That's an input, right?
That's the input. That's the input into that function. That's why I specifically said, be careful when you look at a function, you have to notice the pattern. And here's the pattern. That's what that's the pattern you gave me. You said input squared minus 4 times the input plus 3. I wanted to use the pattern and tell me what to write.
So x plus h squared minus 4 times x plus h plus 3. Right?
Excellent. Good. What now?
So
Good. What is the next step? Notice that I am not working on the difference quotient just yet. I'm working on this piece that I don't have. I'm not working on it yet. So,
x squared
yes?
plus 2xh.
I wanted to catch someone. Okay.
H plus h squared.
Very good. Because we have an agreement, right? We signed it 3 weeks ago. Good, excellent. Now I'm ready to put everything together in the difference quotient. So I'm going to be lazy and do this. So you know what I mean? I'm jumping over this. So now please tell me what to write. Dictate everything from the beginning. Don't try to simplify this. I'm sure you're not going to try to simplify it, right? Good.
I was, but
No, please, no.
So x squared plus 2xh plus h squared minus h plus 3 minus,
Careful, it was a 4H, right?
yeah,
Okay, good.
minus x squared minus 4x
Careful.
plus 4x minus
Perfect.
now your equation becomes the input for the next f of x, correct?
The f of x was you just gave it to me. You gave me f of x. Good. Now here's the trick in all these situations. Every time you're asked to find the difference quotient, you have to remember one very important thing. At the top, all terms without h, maybe other terms as well, but definitely all terms without h must go away. They must cancel out. If they don't, something is wrong. Second thing that has to happen, at the very end, before you write the final answer, the h from the top has to simplify with the h from the bottom. Okay, let me say this one more time. Two things will happen in any difference quotient. The first thing that has to happen is at least all terms without h must cancel out. Other terms as well, maybe, I don't know, depending on the function. But at least the terms without h must go away. If they don't, you have a mistake. Second thing that has to happen at the very end, the h from the bottom must go away. With an h from the top, of course. I can erase it. Right? Good. So now please tell me what to do with the top.
Cancel out x squared.
Yes? Because one is positive and one is negative. Good.
4x.
Yes, one is positive, one is negative.
Negatives.
One is positive, one is negative. How many terms are left?
Just these.
How many terms are left at the top?
3.
What do they have in common?
H.
They must. They must. Otherwise, there is a mistake. Okay, so what is left in parentheses after I factor out an h?
2x
Yes,
plus
yes,
h.
yes,
Yes.
yes. Now I simplify. Please write 1. I don't want you to be tempted to think that there is a 0 in there. And the simplified form is 2x plus h minus 4. And this is for a quadratic function.
We just found the difference quotient for it.
We found the difference quotient for it. So for this function, the rate of change between any 2 points, they're not given to us yet, but if they were, and I would have been given x, then I would have been able to determine the exact rate of change for this function between points blah and blah. Okay?
So this would be the difference quotient, and then it would ask between, say, the point.
No. No, I'm just explaining,
Oh.
connecting it to the definition of the difference quotient. Okay, next function, I would like to choose a function that is rational. Let's say problem 40 on page 150. And we have f of x equals 2x over x minus 1. 2 minutes. I want you to determine the difference quotient and simplify it. And I will take my attendance in the meantime. I would like to write the first step for everyone to see. What will be the first step? Please dictate. Good. So please dictate the first step.
2 times x, sorry, 2 times x plus h.
You didn't say parentheses, so I'm waiting.
Sorry, parentheses, it's,
You can write this or parentheses, but you have to say one or the other, right? Good. So now you're going to put it in the difference quotient, correct?
it's,
You have all 3 pieces. You have the f of x plus h, you have the function, and you have h. Can anyone dictate so we can see how the difference quotient looks like for this function?
So put of f half of x plus h, which is 2x plus 2h.
Very
all
good.
that
2x plus 2h over x plus h minus 1.
Minus f of x plus 2x over
Very good. Over?
h.
Good. We know how to deal with this because we reviewed complex rational expressions. So I'm waiting for the simplified form. Can anyone give us an idea of what you would do next?
So it's from the denominator.
Can you explain how to? It would be 2h over h, right? Because you cancel out everything else.
Never. Be very careful.
I mean, I was asking my question. I don't know how to get rid of. So you get rid of. You just have 2h over h stuff. Okay. So everything else cancels out.
See my gray hair?
Yeah.
I need a hug. No.
We cannot simplify terms. Let's talk about this. Okay? So bear with me. Let's stop for 1 second. X plus 1 divided by x minus 2. Can I simplify this x with this x and get negative 1/2?
No, it's a sum, not a product.
Exactly.
And if it was x plus 1 times x plus 1 over x plus
If it's x plus 1 times x minus 2 over x minus 2 times x plus 3, yes, then I can simplify a factor. Yes, Shane?
Oh, I just wanted to-
So when we add these or subtract these two fractions, what is the least common denominator?
x minus, so open parentheses x minus 1, close parentheses, open parentheses x plus h,
Yes.
close parentheses minus 1.
But then we need what?
Just
We need to multiply the numerator of this fraction by,
X minus
X minus 1,
and we need to multiply the numerator of this fraction by,
x plus h minus 1.
careful, these are not, I have to give you that, these are not easy and they're not user friendly and they're not friendly at all. I have to give you that. So then what is left? Can anyone dictate the numerator?
2x squared
Yes, 2x squared.
plus 2hx minus 2x minus 2h minus 2x squared minus 2xh plus 2x.
Excellent. Do we all agree with the top? Do we all see the top? Because it's kind of squeezed in and it's small. Do we all understand the top? One more time. Let's do this together so we don't make a mistake again. X times 2x, 2x squared, x times 2h, 2xh. Negative 1 times 2, negative 2x. Negative 1 times 2h, negative 2h. 2x times x with minus in front, negative 2x squared. 2x times h with minus in front. And 2x times negative 1 with minus in front is positive 2x. Do we agree with this?
Yes.
These are among the most difficult expressions to work with. I have to agree. Good. Now, what did we say will happen at the top again?
Everything without an h.
At least everything withoh h will go away. And eventually at the very end, what will have to happen?
H on the bottom.
Exactly. There is still an h left in the problem. But this particular one cancels out with a factor of h, not with a term of h. Is that okay? Noah, are you with me now?
Yeah.
Okay, perfect. Okay, so then let's take a look. Can anyone dictate?
The 2x squared would be
Yes.
Negative 2x plus h go away with
Negative 2x with negative 2x
that.
with positive, and negative 2xh with negative 2sh with positive 2xh. Agreed? What is left at the top?
negative 2h over h.
Yes, no.
Oh, it's
So this is a fraction. I'm going to copy it like this. Multiplied by 1 over h. Because I want to save some time, right, in writing. Now I am allowed to simplify because I'm simplifying only factors. What am I simplifying? Which is? H. Goes away. Please write 1 because I don't want you to be tempted to write 0. And then what is left? What is the simplified form of the difference quotient for this function?
-2 over x minus 1.
That's it. As you see, there is an h left in there, but not the one that we had to get rid of.
So you only get rid of the one by itself.
Yes, that one has to go away. Otherwise, we have a mistake somewhere. Let me look and see the time in my video so I can. It's 45. Okay. Questions? Okay. Are you with me? What I would do, I would invent 5 more rational functions, and when I get home, I will try to find the difference quotient and simplify it for those functions, and make sure that you understand the procedure. Okay? I would like to talk about piecewise defined functions now. A new topic. We did do this in our diagnostic quiz, right? And the readiness quiz at the beginning. We did that. I would like to choose another function and graph it. And then I will assume that everyone understood how to graph those, okay? Unless you stop me and say no.
I don't.
Okay. No, I'm going to do one more problem, and then you'll say. Okay, so let's start with, I'm going to pick a problem 38 on page 160. F of x, a very simple problem, 2x plus 3, 4x less than -1, and 3 minus x for x greater than or equal to -1. Is this a piecewise defined function? Because it's defined at least, it can have infinitely many pieces. It can have 3, it can have 4 or more, but it has at least 2. So therefore, this function is piecewise. It's defined in pieces. How many? 2. Okay, when I'm asked to graph, because that's the question here, we're asked to graph, what is the first thing that comes to my mind? Graph. What do I have to find first? Anytime, say it again? Those 2 are important, but every time you give me a function to graph and say, hey, here's the function, graph it, what do you think my mind will go to first? As the very first step, mandatory, always, forever.
Domain.
Thank you. Domain. Without domain, if you remember, Parker had a question a few minutes ago. He said, see, I love it. I cannot do this with a board, right? He said, I'm asked to graph this function, and I'm asked to find the viewing window. And then I said, okay, in that case, we are asked to find the domain. I can graph a function without knowing the domain. So then the discussion went from the concept of the domain to the 4th root. What do we do with the 4th root? Okay, the quantity under the 4th root cannot be negative. So the quantity must be greater than or equal to 0. And that eventually gave us the domain. So coming back here, I don't know what to do with this. I need to find its domain. And I'm looking at this, and I'm going, and also this, and I'm going to ask you to give me the interval notation for the top branch. Assuming you want to write the interval notation, what will you write for that? Correct? Yes? Excellent. Perfect. Assuming you want to write the interval notation for the other one, what will you say? 2 Perfect. Now, please look at this and look at this and identify the domain of this function, please. Do you all agree with everything? Yes? This one, negative infinity to negative 1, negative 1, negative 1 to infinity. We agree? Indeed. So then the domain I know now is this. So then I will start my chart and put negative infinity to infinity and f of x. That's my very first step. Next step, I will have some x values to come up with. But what is the one that I cannot skip? Even if I don't want to have it in there, I have to. I have no choice. Why negative 1? Something major happens at negative 1. How would you explain it to someone? What happens?
One graph starts, one function stops.
Excellent. It's the threshold. Something major happens there. One graph ends, the other one starts. Excellent way to put it. Okay, now look at what I have under negative 1. To the right-hand side of negative 1, going this way, I have a bracket. Going this way. To the left-hand side of negative 1, I have a parenthesis. Since there is no gap, they must touch. Next question I'm going to ask you, which function will I use for this interval? And you have to be very careful and give me only one branch. Which branch? I know it's redundant.
It's 2x plus 3.
Yes, I know it's redundant. I have it right here, but I want to see them close to my chart so I don't make a mistake. What is the other option? Good. What type of functions are these? So I know how many points I need. Of course. So I need 2 points. For a linear function, I don't need more than 2. Okay, so let's go this way and give me an x value, please. Perfect. Please plug in negative 2 and give me the y value. Very good. I'm going to ask you to plug in negative 1, and you should say no. Why should you say no?
It's for that function, it can't be negative.
Correct. Bear with me and I'll show you what happens. So please plug in negative 1 because this will be an open point. So if you plug in negative 1, what do you get? 1. Very good. On the other side, please plug in negative 1. Please plug in 0. And what number should I have here in order to see it? Because I already see it. Of course. 3 minus 3 is 0. Perfect. So now let's graph this function. The first ordered pair from left to right. What will you tell me to plot? Very good. Nope. From left to right, the first ordered pair. Negative 2, negative 1. Next ordered pair, please. Is negative 1 a open point or a full point? It is an open point.
Is that because it's not a greater than or equal to sign?
Because I was not allowed to plug in negative 1. But I have to plug in negative 1.000000000000001. Instead, I plug in negative 1 and I leave it open. Good. Next ordered pair. Negative 1, 4. Full point or an open point? Of course. And then? And then? This is the graph of our piecewise defined function. Can anyone identify the range for me?
Negative 1. I mean, 1.
the range is determined from the lowest y value till the largest y value. Very good.